Welcome viewers. In this video we'll see the problem related to the series and parallel combination of resistor. The detailed explanation of series and parallel combination of resistor, the derivation and explanation available in previous video. The link is available in the description box. You can see the detailed explanation of the series and parallel combination. This video related to the problem based on series and parallel combination of resistor. First we will see the formula. The series combination. If the resistors are connected in series, mean the resultant resistance will be R1 plus R2 plus R3. If three resistors are connected in series, mean the resultant resistance is total resistance is nothing but sum of individual resistance. You have to add all the resistors R1 plus R2 plus R3. In case of parallel combination, if three resistors are connected in parallel, the resultant value will be R1 R2 R3 divided by R1 R2 plus R2 R3 plus R3 R1. Suppose the two resistors are connected, mean R1 R2 divided by R1 plus R2. So based on this formula, we'll go for the problem. The detailed explanation available in previous video, you can see that the link is available in the description box. Now we'll go to the problem 1. So the circuit is available. In this circuit diagram, we need to find the equivalent resistance and current flowing through a source of 12 voltage for the circuit shown below. So for this circuit diagram, the combination of resistors available, we need to find what is the total resistance, equivalent resistance, as well as what is the current flowing through this the source 12 voltage. Now we'll see this. How will you find the series and parallel resistor? If the current flow, the same current is flowing through the resistor, that resistors are connected in series. If the current is diverted at this point, that means that two resistors are connected in parallel. So based on the current value, we can easily identify whether it is connected in series or whether it is connected in parallel. Right? If the same current flowing means series. If the current is diverted means parallel. Right? So we start from here. We'll say that the current is I1. The current flowing through the source 12 volt source is I1. So the I1 is flowing through 25 ohm. So at this point, what will happen? The current will divert. Because of branch, it is diverted. I2, I3. What is the meaning? These two resistors are connected in parallel. Right? This 100 ohm and 50 ohm are connected in parallel. Again, this I2 is flowing through 100 ohm. At this point, again the current is diverted. This I5, I4. What is the meaning? This I4, I5. So this 5 ohm and 10 ohm, these two are connected in parallel. Right? So these two are connected in parallel. These two are also connected in parallel. So by seeing the current flow, we can easily identify. So the I1 is flowing through 25 ohm, that is divided into I2 and I3 through 100 ohm and 50 ohm. Again that is divided into I4 and I5 through 5 ohm and 10 ohm. So these two are parallel and these two are parallel. Now how will you simplify this? So in this circuit diagram, this type of circuit diagram, we have to follow from the load end opposite to the source. We cannot simplify from this source end. We can follow from this opposite to the source end. Normally it may be taken as a load end. From load to source we need to follow. We cannot simplify from source to the load. We need to follow from this side to source. Right? We need to follow from this end. So first we will follow this end. That is, these two are connected in parallel. We will go from right hand side to left hand side. Right? So by seeing this diagram, it is clear these two are connected in parallel. So if these two are connected in parallel, we can find the equivalent resistance. So that calculation available here. So this 5 ohm and 10 ohm are connected in parallel. This 5 ohm and 10 ohm. We'll take this is R1 and R2. For simplification purpose, we assume that 5 ohm is R1, 10 ohm is R2. What is the total resistance? R1 R2 divided by R1 plus R2. So this is the formula for when two resistors are connected in parallel. So what is that? 5 into 10 divided by 5 plus 10. That is 50 divided by 15, 3.33 ohm. Resultant will be 3.33 ohm. So these two resistors are connected in parallel. By inspecting the current, we easily identify these two are in parallel. So the equivalent resistance of these two parallel resistor is 3.33 ohm, right? Now we can replace these two with 3.33 ohm, right? That is available in the next diagram. See this, right? That parallel combination now converted into 3.33 ohm. What we calculated is replaced. Now from this diagram it is clear that these two are in series. See, the same current is flowing through 100 ohm as well as 3.33 ohm. The same current is flowing. What is the meaning? These two are connected in series. If series mean R1 plus R2. We will take 100 as R1, 3.33 as R2. So the resultant, if it is connected in series, R1 plus R2. 100 plus 3.33 ohm, that is 103.33 ohm. These two are in series. The equivalent resistance will be 103.33 ohm. Now we'll replace this with this value. So after replacing, what we got? 103.33 ohm. So these two are other two resistors available. So from this diagram, it is easily we are able to understand these two are in parallel because the current is diverted here. Current flowing through 25 ohm is diverted here. So these two are in parallel. Now if we take this 103.33 as R1, 50 ohm is R1 and 103.33 as R2. Now we'll find the equivalent resistance. What is the equivalent if it is connected in parallel? R1 R2 divided by R1 plus R2. 50 into 103.33 divided by 50 plus 103.33. So that is 5166.5 divided by 153.33. So that is nothing but 33.69. These two resistors connected in parallel, the equivalent resistance will be 33.69 ohm. So now we can replace these two parallel resistor with single resistor 33.69. So that is replaced here. 33.69. Now from this diagram it is clear these two are in series. The same current is flowing through 25 as well as this 33.69 ohm. So what is the resultant sum of these two, R1 plus R2? We'll take this 25 ohm as R1, 33.69 as R2. So 25 plus 33.69 is 58.69 ohm. So these two parallel combination can be replaced with a single resistor 58.69, right? So for the simplified diagram is available here. See this, now it is replaced with 58.69. So this is the total resistor. Step by step we find the equivalent resistance by using series and parallel combination. Finally what we got? 58.69 ohm. So that is nothing but the total resistance. One more question, we need to find total current or source current. I equal to V by RT. V, applied voltage divided by total resistance. So 12 divided by 58.69. The supply voltage is 12 and the resistor is 58.69. So it is 0.204 amperes. So the current is 0.204 amperes. So in this problem, by solving the problem step by step using a series parallel combination, finally we got the answer. The equivalent resistance of the circuit is 58.69 and the source current or total current is 0.204 amperes. Now we'll go to the next problem. So in the second problem, we need to find the total power dissipated in the circuit zone is 18 watts. The total power in the entire circuit is 18 watts. find the value of resistance and current in the circuit, right? So in this diagram, the 12 voltage is applied to these two resistors, the set of resistor. These two resistors are, we can easily see the parallel. These two resistors are another parallel combination. This 8 ohm, this resistor value is not known. Another parallel combination 4 ohm and 16 ohm, right? So the total voltage is available, 3 resistors values available and 1 resistor value not available. So we need to find what is this resistor value and also what is the current. One more value what we have, the total power dissipated in the entire circuit is 18 watts. We have one more data, what is available as total power is available. So by using the total power and other terms, we need to find what is this total resistance and what is the total current. Now we'll follow with the total power. What is the total power formula? V square by R. Total power equal to V is two formula available. I square R or V square by R. Right? Here we can use V square by R because the total power is available, voltage is available. So easily we can find the total resistance. I square R we cannot follow because I square means the current value is not available. So the total power is 18, voltage applied is 12 square divided by RT, total resistance. You cross multiply, interchange these two values. So RT equal to 12 square by 18, that is 144 by 18, that is RT equal to 8 ohm. So now we got the total resistance of the circuit is 8 ohm. From the total resistance we can easily calculate the total current. I equal to V by RT. V is available 12 voltage. RT is 8 ohm. So it is 1.5 amperes. Right. So we got the total power by using the formula. We got total resistance. From the total resistance we calculated the total current 1.5 ampere. So the one question is identified. Another question, we need to find the R value. The R value is not available. This is the total resistance. One resistor value is not known. We need to find the total resistance. I will go for that. So from the diagram it is clear 8 ohm and R are connected in parallel, that we already discussed. 4 ohm and 16 ohm are connected in parallel and these two are connected in series. Two parallel combination that is connected in series. So what is the total resistance? This is first parallel combination, 8 R1 R2 divided by R1 plus R2, 8 into R divided by 8 plus R. Similarly another parallel combination, R1 R2 divided by R1 plus R2, 4 into 16 divided by 4 plus 16. Right? So this R value is not known, but this RT is we calculated. RT is 8 ohm, right? This 8 ohm is calculated, RT value is available. So in this equation only this parameter is not known, other things are available. So you can easily find the value of R. Right? Now we'll go for the simplification. Now substitute this RT equal to 8 ohm. So 8 equal to 8R divided by 8 plus R, that is 64 divided by 20. Now go for further simplification. 8 equal to 8R divided by 8 plus R plus 64 divided by 20 is 3.2. Now bring this 3.2 in the left hand side. So 8 minus 3.2. This plus 3.2 become minus 3.2 equal to 8R divided by 8 plus R. So 8 minus 3.2 is 4.8. That is equal to 8R divided by 8 plus R. Now we'll go for the further simplification. Now cross multiply this. Cross multiply so that 4.8 into 8 plus R equal to 8R. Now multiply this 4.8 into 8 plus 4.8 into R, that is equal to 8R. So 4 into 8 is 38.4 plus 4.8 R equal to 8R. 38 plus 38.4, bring this 4.8 in the right hand side, so that 8R minus 4.8R, while going this side it will become minus. So that 38.4 equal to this 8 minus 4.8 is 3.2R. So 3.2R can be 38.4. It is interchanged. For simplification, 3.2R equal to 38.4. Both are interchanged. So R equal to 38.4, bring this 3.2 in the denominator. 38.4 divided by 3.2. So R equal to 12 ohm. Right? So from series parallel combination, we calculated the total, the resistance, unknown resistance is 12 ohm. So in this problem, from the given total power, we calculated total resistance of the circuit, then total current. From the combination of resistor, we already know the total resistance, so that the unknown resistance R value is calculated. Now we'll go to the next problem. So in the third problem, there are three resistors available: 30 ohm, 25 ohm and 40 ohm. You can easily see that these are connected in series. The applied voltage is 200 voltage. So we'll take this is R1, 30 ohm is R1, 25 ohm is R2, 45 ohm is R3. The voltage drop across this 30 ohm is V1. Voltage drop across 25 ohm is V2. Voltage drop across 45 ohm is V3. Right? What is the question? Total resistance. We need to find what is the total resistance. What is the total current? What is the potential difference across each element, each resistance? Right? Total resistance, total current and potential drop across each element, that is V1, V2, V3. How will you find the total resistance? It is easy. If it is connected in series, the total resistance equal to sum of individual resistance. RT equal to R1 plus R2 plus R3. 30 plus 25 plus 45, that is equal to 100 ohm. Right. Then what is the total current? I equal to V by R. V is 200 voltage. R is now what we calculated is 100. So 200 by 100 equal to 2 amperes. So we have easily calculated total resistance, that is sum of individual resistor. From RT value, by using V by RT, we calculated total current also. Now we'll go to the potential drop across each element. That is also very easy. V1 equal to I into R1, because current is same in entire series circuit. So the current will be I. Potential drop across R1 is V1, R2 is V2, R3 is V3. So V1 equal to I into R1, that is I is 2 ampere, we have calculated, into R1. R1 value is 30. 2 into 30, 60 voltage. V2 equal to I into R2. I is 2 ohm, 2 ampere into R2 value is 25, that is 50 volt. V3 equal to I into R3. The I value is 2 ampere into 45, 90 voltage. Right? So the potential drop across V1 is 60 voltage, V2 is 50 voltage, V3 is 90 voltage. By adding all this, we got 200 voltage, because the 200 is the applied voltage. So by adding this, we got 200. So the answer what we calculated is correct. So in this problem, we discussed what is the total resistance, then total current and potential drop across each resistor. So in this video, we discussed the three different problems related to the series and parallel combination of resistor. The series and parallel combination of resistor, the derivation available in previous video. Link is available in the description. You can see that. Thank you.